Thanks very much. So to introduce myself, Andrew Fernie, working at Technology and Innovation Group at SÉRI. I'd like to thank SÉRI Montréal for inviting me this evening and also for setting this 9-minute time limit, which I can see is going to be a real challenge. So my watch is out there. So talk about virtual reality this evening, but first kind of introduce you to CAE. Many of you have probably heard the announcements in the press every so often that CAE's gained another contract for a flight simulator, but in reality we're doing a lot more than flight simulators. We're focused on delivering training solutions. So basically taking people that are performing dangerous tasks and providing them a safe virtual environment to perform that training in. Traditionally, we've been more on the aviation side, so vehicles, whether that's civil or military aircraft, but more recently applying it to the healthcare industry to train the doctors and nurses of tomorrow. Right. So, part of our work producing these virtual environments in which people can train safely. A lot of news these days about virtual reality, but it generally tends to be focused on the helmet-mounted displays, 5 of which I've put up on the slide here. Working from the top left, we have the Oculus Rift product that came out of the States, a company that was bought for $2 billion by Facebook last year. They can see the value in it. We have Samsung Gear VR, so here you can take your smartphone, download an app from the web, put on some pictures perhaps of your last vacation, a 360-degree photograph, or a game, hold it up, turn around, and see everything around you. Microsoft HoloLens, something came out, I think they started shipping 30th of March of this year, which enables you to take a virtual object and position it in space. I could take perhaps a statue, put it on this table here. No matter where I move around the room, I see the statue sitting on this table. Google Cardboard, much like the Gear VR, but only for about 20 bucks, or you build it yourself and plans you download from the web. The last one, VR Vana Totem, so another Montreal company. They're based just probably a 10-minute walk from here, but this is a product they're supposed to be introducing in the coming months. So all new, but is the idea? No, it's not really new. In fact, if you look on the 2 pictures I've got up here, in 1989, it's a helmet-mounted display in the picture. It was on the cover of Aviation Week, one of the biggest aviation industry magazines in the world. Or 1995, another helmet-mounted display built by CAE, which was used in a real helicopter owned by the National Research Council in Ottawa. So the pilot was actually flying the real helicopter, sitting in the seat, but the only thing he could see was a view from cameras that were relaying that picture up to his helmet. So if that was what we were doing 20 years ago, what are we doing now in VR? Well, first let's take a step back and talk about what VR is. So VR is a way of presenting a computer-generated environment which is explored by the user and experienced by the user in a natural way. How do you do that? Well, you start off with models. So in this case, I've got a model of a car or a model of perhaps a city center with roads and buildings in it. So here you have modelers and artists that put together these 3-dimensional models in software. Those are then brought into a computer system, hardware and software, that produce pictures that can be seen on some form of display, either the helmet-mounted display, much like one of the ones I showed on the previous slide, or in a more traditional monitor. At the end of the day, equipment puts all that together, displays it, and in fact creates a virtual world, an artificial world for the viewer. In this case, we're seeing it through the helmet-mounted display. So, some cases we actually use a true VR, which blocks out the rest of the world. So you can imagine there we have a technician in the back cabin of a helicopter doing a search and rescue mission. He can look out the cabin door, he can see the victim in the water, lowers a winch down and picks him up. And you can do all that while standing in a standard office room. Another extreme, something more called augmented reality. Okay? So augmented reality takes the VR, but it adds something of the real world too. So here we have a real cockpit, very much physical instruments, physical controls, but as soon as the pilot looks out the window, he's seeing a virtual world. Talked a lot about the displays that are used for VR, but just as important is the software and the models of the environments that people work in. In this case, the model of Dorval or Trudeau Airport these days that many of our airline customers fly with. So here you can see we started with satellite imagery that produced a picture of the ground, then had modelers come in, take photographs of the various buildings at Dorval, put them all together, then create models of the aircraft, place at the various gates. So now when the pilot is taxiing out from the gate to the runway, he has a realistic view of the world. Objects move, so in this case trucks, and very realistically they go right through the stop signs. So it's the type of thing that we do. We've got about 250 of these airports available for customers around the world. So, conclusion, virtual reality really, I mean, it sounds new, but it may not be as new as you really have thought. And Montreal, through companies such as CAE or VRVANA that I mentioned earlier, universities, the computer graphics industry, has really been a world leader in the field, and we continue to innovate. Okay? Their success is not just an engineering skill, it's really from bringing together the skills of engineers, modelers, and artists who are dedicated to producing an environment, an immersive environment, in which people can train safely.
So you haven't told us about the health, le secteur santé chez CAE. Qu'est-ce que vous pourriez nous dire à ce sujet-là?
Okay, so the simulator for healthcare produce a mannequin, so it looks like a body or a section of a body. For instance, the doctor. Oh wait. So if the doctor, for instance, wants to practice an ultrasound examination, he can take a virtual ultrasound wand, place it against the surface of this mannequin, and as he moves it around, he's going to see on his instrument an accurate simulation of the ultrasound system. Okay? Do that. They can also simulate inserting, I think they call it a central line, where they go in through one of the veins, feed a line up. They can do all that on the models. So it's an interesting area. You know, pilots, it's taken for granted that they will perform training in a simulator both before their first flight on the airline, and they're also going to come back into the simulator every year to practice. Medical, we believe we can take the same methodology forward. Yes. Okay, merci.